Okay, time for percent composition. This one should be pretty short because we just have a couple of problems to do. Percent composition essentially tells you what percent by mass each of the elements in a compound make up, so it's all about their molar masses. The first one's pretty straightforward because it's just NaCl, one sodium, one chlorine in the compound. So what I like to do is write down what compounds I have. Start with sodium. If you look up the molar mass of sodium on the periodic table, it is 23.0 grams, and there's only one of them, so just going to be 23.0 grams. Now we're going to be putting this over the total mass of the NaCl compound, the whole thing. But what I like to do is to do both of the top parts, because then as soon as I'm done with the tops, I can just add them together, and that's going to give me my total mass on the bottom. So there's just one chlorine, and chlorine is 35.5 grams. Put that on bottom. On top. Now for bottom, we're going to just add those two together. So when you add those two together, the overall mass of this entire compound is 58.5. As with the percent, you put the part on the top, the whole on the bottom. Make sure you write times 100. And then you're going to divide and multiply by 100. Now in terms of sig figs, they don't have sig figs because if you notice, the problem does not give you any original measured values. So therefore, we are always going to do our answers to 1 decimal place. Go ahead and make yourself a note on your paper that you are always going to go to 1 decimal place. So when you divide those two, you will get 39.3 if you round to 1 decimal place. And I usually put what the substance is behind it. So that is 39.3% sodium. And then for this one, comes out to be 60.7% chlorine. And you can always double check. Those two answers should add up to be 100. It might add up to be 99.9 or 100.1 just because of rounding. But as long as you get one of those three sums, then you'll be fine. So that's the basic idea. Now in the second one, we have hydrogens, we have nitrogens, and we have oxygens. So we're going to have 3 different percentages for this one. Again, I would always start with the top of the ratio and do those masses, and then you can just add them together. So we have 1 hydrogen. Hydrogen will be 1.0. We have 1 nitrogen. Nitrogen will be 14.0. And then for oxygen, we have 3 oxygens. Each one is 16.0, so that gives us a total of 48.0 for the mass of all 3 oxygens. Add those 3 masses together, and you're going to get 63.0. Notice this time I didn't put the grams unit in on my actual work. You don't have to put units in the work part unless it's stoichiometry. If it's stoichiometry, they have to be there. But if it's something like this, you have the option, you could do it, or you don't have to. You do have to actually write out times 100 though, or else your math won't make sense. So when you divide those through, you get 1.6% hydrogen, 22.2% nitrogen, and then 76.2% oxygen. So those would be your answers. Double check those answers by adding them up and making sure, in this case, they do add up to be 100. For the last problem, and actually this problem is not on your notes packet, so go ahead and make yourself some space and put calcium phosphate down, Ca3, parentheses PO4, parentheses 2. I just want to try this one just because there's parentheses and make sure everybody's good on distributing those parentheses out. So we have calciums, phosphoruses, and oxygens. So again, we're going to make our little ratios here. We're going to put our individual masses of those elements in the correct places. So for calcium, we have 3 calciums. They end up with a total of 120.3, okay, for the mass of those 3 calciums. For phosphorus, just 2 phosphoruses. You see here it says PO4 2, which means there are 2 PO4s. So in terms of phosphorus, we should have 2 phosphoruses accounted for, each one 31.0, so I end up with a total of 62.0. And then for oxygen, you can see that there's 8 oxygens here. So if you take a look at that, it makes sense based on this parenthesis. And so we're going to have a total of 128.0 grams for oxygen. Now to get the bottom, simply just add up all three of those values, which add up to be 310.3. And then multiply times 100. Again, make sure you show that step, please. So I will have to mark you off. And you end up with 38.8% calcium, 20.0% phosphorus, and 41.3% oxygen. Again, add those up. This time we add up and get, it looks like 100.1. We said that was okay, and that was just due to rounding. Let me know if you need any help.